Hmm, okay. We did some subplots in the last class, right? Um, and today we'll try to finish up matplotlib and we'll see if we can cover more. Okay. Let me start sharing my screen. Okay. Is my screen visible to everyone? Yes, no, yes, no, yes, no. Okay. So since my screen is visible to everyone, I will assume full black. Avinash, maybe refresh or something. Because for most of the people it's visible. Okay. Okay. Um, if now anyone has any issues with the visibility of the screen, it's possibly because you have a bad internet. It's not my fault. Okay. Okay then. Um, Up until now, what we did was like just explore. Okay, we um we had two sort of interfaces, object-oriented interface, and then we had this PyPlot interface. And I said that, okay, PyPlot is not so flexible, and it's good if you use object-oriented interface because it's much more flexible and so on and so forth. Okay. When you want to plot something really quickly, I said use PyPlot. Okay. When you want to plot something really advanced and you want to make it detailed, use object-oriented interface. Okay. How do you do an object-oriented interface? Nothing fancy. You just basically use um, subplots and get figure and AX. Okay. But if you want to do just a basic PyPlot thing, then you just need to do like you can just do plt.plot and it should be able to plot your stuff. Okay, so it's nothing fancy. Okay, now let's incorporate other things that we have been using. Basically, we have been using something called as pandas. This we have already covered, right? And in pandas, we learned something about series, if you know. Okay, if you remember, we said we have series. And then we also learned something about NumPy, okay, last time. And we said in NumPy, you can actually generate random numbers, okay, as such, using random, and so on and so forth, okay. And then in series, we were able to define some index, if you remember. If you don't, I hope you guys have practiced it at your own time, like when you got time or something like that. Okay. So, okay. And then we say periods and we are saying 1,000. Okay. And that's okay. Let's first try to see what do we get in TS and then we get this. It's really beautiful. We are getting like 1,000 sequences. It started from 2024 up until 2026 and so on and so forth, filled with random numbers and so on and so forth. Right? This is what we get. That's what we are doing with random numbers here. And this is the index. That's why we are getting index here. All cool. Right? This is how we used to create our series. Correct. What if I want to get some cumulative sum? I can get a cumulative sum and a series has um, this function, okay, via which we can get cumulative sum, okay. And we are saying just update TS and get a cumulative sum out of it. And we can see here. So we get cumulative sum. What cumulative sum does is basically it keeps on adding, and so on and so forth. Okay. So that hence why we get a cumulative sum at the end in total. Okay. And then if we want, we can actually plot it directly. Right. This is basically we are using PyPlot interface, right? We are using PyPlot interface, and by using PyPlot interface, we are basically able to get a nice, amazing graph. And then it says, okay, we have some like basically a range of date from X to Y. And then this is the sort of data that we are getting. Right now, this is completely nonsense. I mean, I'm just showing it as an example, but these things might come in handy. Okay. Just as a question, how many of you know what is a cumulative sum? Because I know a lot of you might be confused because I just rushed it. So just type on chat, what is a cumulative sum and what happened here within the count of 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Seriously, no one understand or what? Summation will done, no, adding each value, sum of a given sequence. I mean, everyone knows it's a sum, but like what, how is this adding up? So cumulative sum is basically, it is adding like first value, then to get second value, it is adding first value and second value. To get third value, it is adding third value, this value and this value. To get fourth value, it is adding this value and this value. Okay. This is how it gets cumulative sum. Okay. Correct. Present value is added to the previous ones. Correct. So that's what cumulative sum is. Okay. You remember we had this data of car sales, right? We had this data of car sales, read CSV, and then we had car sales CSV, right? We had this data, and let's see, car sales. Okay, we have this data. This was nice, amazing data that we had, right? And if we want to get what car price, this is how I think we can get car price. Uh, mm, okay, I completely forgot. We need to do regex true or something, right? No, regex false. Okay, I don't know. I don't know. What was the what was the syntax last time, guys? I will have to open previous notebook. Uh, I completely forgot. So how did we get the price? So here we had and no. Right, this is the one actually. Okay, yeah, I got it. So yep. We got this car price, and then we can have car price, and we can see what is the type. Type is obviously Int64 because that's what we said in here, right? The last type is Int64. Okay. Um, okay. What else? Car sale date. We can have a car sale date, right? We don't have a date. So let's have a car sale date. Car sales, and let's do a sale date. And now, if you saw this one, okay, I'll take up this one. If you saw this one, just quickly type, how should I get car sales date? Okay, for your reference, I'll paste it here quickly. Okay, what you need to tell me is what should I enter here to get sales date, okay, for this data frame. Type it. You have 1 minute. 1 minute to do it. Hint is you need to use something like this. Try. It's not so complex. Are you guys even trying? Even if you're giving wrong answers, it's okay. I just want to see like if you tried at least. Okay. The question is, we want to get car sale date. Okay. You should ask it 1 minute ago, though, but it's okay. I say, give me this car sale date, okay? And you can take reference from this particular thing. That's why I pasted it here. Okay. I want to get car sale date. I want to generate car sale date for all of these data frame and points. Okay, data points. So for Toyota, for Honda, for Toyota, BMW, so on and so forth. Okay, we want to get car sale date. So we need to generate it. How will we generate it? So what would be the syntax? How would it look like? Have you guys practiced pandas at all? Or are you guys just coming on here and like just watching this? Watching me talk and then going and back to sleep and Okay. Aditya, that's correct to some extent, but you didn't put any thought into it. Again, Avinash, it's correct to some extent, but you didn't put any thought into it. You don't need to do a series thing here, actually. Okay, I'll do it now. Guys, please practice it at home. Please practice it at home. Okay, try to develop some sort of like thinking. See, ML I can teach only syntax and stuff, but there is this whole logic building that you guys need to think carefully. Okay. Uh, Niharika, that's correct, but very out of the chart. Again, you need to put some thought into it. Okay. So first of all, we don't need series because it's already a data frame. We usually take in series when we don't have a data frame and we want to create a data frame out of, because series is a single dimensional and data frame is already two dimensional. Okay. Hence, we already have access to one dimensional. That is what we are doing. We have one dimensional data. We can directly assign values. Okay. Hence, we don't need series. That's one. Now, date range. This is what I have used below as well, right? What can I do? First, you need to think. Okay, this is a car sales date. If today is 2024, maybe the sales started from 2023 or so. Okay, so I can put 2023. And this is also fine. If you put 2024, it's completely fine because we are just practicing. However, you need to put thought into it. Now, this is where you all are wrong because you need to be smart. Okay, length of car sales. Okay, length of car sales. Why will you hard code? Why will you hard code things that you already have? Okay, you need to use all the tools that is there with you as such. Okay, now you got this. Okay, okay. I want, now I want this quickly. At least you guys should be able to do this one. Give me car sales, total sales. Okay, I want this column as a cumulative sum. Okay, but this cumulative sum should be of float type. Give me, what should I type here? What should I type here? Yeah, cumulative sum, that thing is correct. I need full syntax. Like, what should I type here? Just doing does not give me anything. Just doing this is also wrong. Okay, this is wrong. So what should I type here? Think about it. We need total sales. Okay, we already have price. Maybe we can use price or something like that, right? See, that's the point. When you are doing machine learning, you have some data and you don't have some data. You need to derive data out of the data that you don't have. Okay, no one will tell you when you are hired, no one will tell you that this is what you need to do. This is something you need to figure out looking at the data, which is this table that is already what you can see. This is what you need to see. And that is wrong, Avinash. Okay. Ritika, that is correct. That is correct. The only thing that you missed is having type as float, but other than that, it's correct. So all we need to do is car sales. Okay. Car sales price dot. Okay, let's not convert it to float, but if I have to convert it to float, I'll do as type float as well. That's the only change it will be there. Okay. So anything else is wrong. Car sales. So now you can see cumulative sum here. That's the total sale. And we are taking out cumulative sum, deriving it from the price. This is the price at which car was sold. This is the data that we got. And now we wanted to have total sales. Guys, again, you will have partial data. You need to derive meaning out of that data. For that, you need to open up your brains, okay? No one will spoon feed you. And when you are hired, you will possibly be working alone on this data. So no one will tell you that, oh, do X and Y like this. You need to think, okay? You need to develop this thinking. Okay. We got total sales, right? What can we do? Okay. Car sales, let's just say, and we want to plot. We want to plot and we want to say that x-axis is basically sale date, right? And do y-axis as total sales. Okay, right? And boom, this is the sale date from January 2023, month 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay. Now let's think more. Okay, what else can we do? Okay, I want to create, I want to create. Now you have seen the syntax already. Okay, I want to create a plot. This should be a scatter plot. Okay, this should be a scatter type of plot. And I want X label to be odometer, which is this odometer kilometer. And I want Y label to be price. Give me syntax. Here, what should I type? What should I type? What should I type? 1 minute. And not even 1 minute, man. 30 seconds. One, two, three. X-axis should be odometer. Y-axis should be price. Okay. Right now, only focus on what I'm telling. X-axis should be odometer. Y should be price. And I want a scatter graph. Tell me how I can do it. But okay. So Janya, that's correct, but it's not a scatter plot. I said I want a scatter plot. What you said, it's basically a line graph. Think, guys. I hope everyone is studying this because you guys want to get a job in this at some point. I remember telling something called as kind. You can just say scatter. That's it. And then we have a scatter graph, odometer, price. Boom. All you need to use kind. If you define a kind, you can actually do it. Okay. Okay. Without kind, it will give by default, it always gives you line graph. Okay. If you want a different type of graph, you need to provide it with the kind that you are expecting it to have. Okay. Uh, okay, guys. Another one. Create a data frame which should have X as random numbers. Okay. Um, of shape 10 and 4. Okay. And should have columns A, B, C, and D. Okay, give me a syntax for this. Guys, I want to create a data frame which should have X as random numbers of shape 10 and 4 and should have columns A, B, C, D. We have done this a lot of times up by now. If you would have a Python stuff like some compiler or maybe a Jupyter notebook open in your system, it will make your life easier. You can answer me fast. No idea? Then 9, 8. Okay, I got one. Cool. So what you are saying is you defined a number of rows 10, number of column 4, and then you are saying NP random rand 10, 4, columns A, B, C, D. This is correct actually. This is correct. Sairam, yeah, that's correct. What you just sent. But since we are using Jupyter, I will do it in a much easier fashion. Okay. So yeah, Siva, that's correct. And then we can have something like this. Right. A, B, C, D. Cool. Right. Now, if you want to plot a bar graph onto it, we can just say plot bar there. Amazing bar graph. Right. You can also plot it like so. That's one way to do it, right? df.plot.bar. And there is another way, which is like you can say df.plot, and then you can say kind and bar, and it should do the same thing. Okay, it should do the same thing. Okay, quickly in 10 seconds. Okay, in the under the count of 10. For car sales, plot a bar graph. Okay, for car sales, I want a bar graph. For make, okay, for make odometer. Okay, for make and odometer. I want a bar graph for make and odometer. Give me the syntax. How can I do it? 10 seconds. 10, 9. You already did it. You just need to make some one change. 8, 7, 6, 5, 4. Sai Ram, that is correct but incorrect because again it is a line graph and I am saying plot a bar graph. Niharika, correct but incorrect. It is a line graph. Right. Saujanya, you are in you are correct to some extent, but you missed the second point. You are not using make. Okay. Okay. So this is plot. Okay. And then all you have to do is, oh, I'm not even typing. I'm sorry. Uh, I typed it somewhere else. Okay. If anyone has any questions, you can just type. Don't raise hands because I will just take note of it from there. Okay. That's it. Okay. Now, if I want a histogram or something, okay, let's just say if I want a histogram, what can I do? I can say, mm, I can say something like this. Okay. Now, what is bins here? What is bins? Bins is basically the width that we are expecting. That's the bins. That's it. Okay. If you remove it here, then it will give the default sizing. So you can see the difference. Bins there. You see sizing differs. That's what the bins is. Okay. Let's try with another one. We also had this amazing data set that we never used up until now. Read CSV, and we had uh, heart. Oh, I didn't. I thought I had heart disease in here. Yes, we do. No, we do. We do. We do. Why? Read CSV. Read CSV. Heart. Ah, the same thing. Yeah, heart disease. Okay. Heart disease. Cool. Now this is a much bigger data set, and we have a lot of things in here in heart disease data set, right? We can do a lot of things. So, firstly, now you've already done this. Draw me a histogram on age. Give me a syntax for this to plot a histogram on age. For heart disease, this is the age column. I want to draw a histogram. Do it fast. Shouldn't take so much time, guys. You are already watching me do all of this. So you can just do it. It's not rocket science. Oh, this is overall. Wait, we need to get histogram for only age. Exactly. Yeah, Raja, that's right. Okay. What else can we do? We can set bins here to 50 bins equals 50 to make it much more visible there. Right. What else? What else can we do? Now, okay. Assume we want to now use object-oriented interface, right? Then what can we do? If I want to use object-oriented interface in here, I can plot the same histogram. Okay. Plot the same histogram. What is it? Plot history on overall data set. Okay. And then I can say, make the figure size to something like 10 and 30 and do subplots equals true. And now you see for age, for sex, for CP, we have different graphs, different histogram graphs, right? Okay, what else can we do? For example, I want to get data of people who are over 50, then give me heart disease, heart disease, age, okay, where age is over 50. Okay. And that's how I can get people whose age is over 50. Okay. Now, if I want, I can plot, let's just say if I want to plot a scatter graph. So I said we need to use something called as kind. Okay. We use kind. Okay. X can be age, Y can be can be cholesterol. Okay, so cholesterol and C can be target. Okay, and then figure size can be 10 and 6. And let's see. Okay. So C is this amazing side meter, okay, gauge that we get. Okay. Let's see here. Cool. Where it basically gives you some sort of shade. Okay. What means what? We have drawn a scatter graph based on, okay, this is the age, this is the cholesterol level for people of target range from 0 to 1. Okay. Okay. What else? What else can we do? What else can we do? So for example, let's do a pure subplot method. Okay, this is OO method. So we want to have a figure of size 10 and 6. Okay, we want to do over 50 dot. Okay, we want to do the plot. Basically the same thing as above. Basically the same thing as above. The only thing that will change from here is the last one where we were defining a figure size directly. Right now, we are just saying use X, these X's, okay, that we have already defined and plot this. we get the same thing. Okay. And if I set X limitation to 45 and 100, okay, that's the limitation that I'm setting to 45 and 100. Okay, this is the limitation I'm setting. And I am saying keep the values, keep the values. So over 50 target values, over 50 target unique. Okay. Then we are saying plot a graph of this figure subplot, right? This we have already done. And then have this axis, plot a scatter graph, okay, with over H, this, and C should be target. So let's see what do we get. Boom. Okay. Now we can technically clearly differentiate, because now C is actually it's changing colors, okay, and we can differentiate which target is 1 and which is 0. Okay. Let's say we want to have title something like this, age and cholesterol, and then we want to add a legend. Okay. So we want to add a legend and say legend scatter elements, title is target. Mm, and we want to add a horizontal line while taking out a mean. Okay. So XH line basically means horizontal line. Okay, legend is basically some sort of label. You will see what it means when it is plotted. Okay, and then if we want to have two rows of plot, right? You remember this when I was telling you about this whole OO plot, right? We have two rows, hence we have two axes, AX0 and AX1, and then one column, okay? And then we have one sharing, which is true, okay? And let's draw this. Cool. What do we get? So we get one this. Okay. Something looks off. Something looks off. Um, Legend elements, target, this is cool. Okay, this is right. This is right. Okay. And let's try this. Right. Up until this point, this is right. And then if I want, okay. And if I want, okay. And let's try to see. Basically, nothing happened. Maybe I missed somewhere. Okay. Basically, I missed somewhere. I messed up somewhere. Where did I messed up? Until this point is fine. AX0, we take out main, we take out subplot. This is there, AX0, right? X1 legend. This is there, right? Yeah, now we see it. Right. Now we see it. Okay. So what's happening in here? What's happening in here? This is still not complete. AX0, basically, I did all the AX0 thing below. So we can remove all of this actually. We can remove all of this. So let me just delete it so that it's not confusing for you guys. Let me just delete it. Um, and we are saying, yeah, right. Okay. Okay. And we also need to have a mean line here, right? So let's have a mean line here. Uh, okay, cool. So what is happening here? We created a figure, okay? We are using object-oriented interface, right? And then we have drawn two sort of axes, AX0 and AX1, okay? And we are doing a subplot, okay? We are saying give us two rows and two columns, okay? Then we are saying in the figure size, the figure size is 10 and 8. Okay. Figure size is 10 and 8. Okay. And share X basically here means shared axis. Okay. So it is sharing axis, sharing X and Y axis. Okay. So what this means is it says that all subplots will have the same X axis, meaning the X axis limits and ticks will be synchronized across subplots. Okay. And same share Y axis. If you would give it share Y, then it means plots will have same y-axis. And here we are setting share x as true. That means we are saying all subplots will have the same x-axis, meaning x-axis will limits and takes will be synchronized. Okay, that's it. Not a complex stuff. Then we are saying set, and set we are setting title, label, and so on. We have already done this. Okay. Then we are using legend. Legend is this. Basically, this is small thing that is legend. Okay. We are setting legends, which basically tells our graph that okay, in here dark circles are 0 and light circles are 1. So this way we can see that how many dark things are in there in basically in this graph. Okay, then we are setting a mean line. Okay, we are setting a mean line, axh line. Okay, we are setting a mean line, and we are saying okay, just creating this new variable, something like that, and setting a and getting a mean on top of y-axis. Okay, setting the color to blue or something, and line style should be dashed line. That's what we are saying. Okay, and label would be average. Okay, that's what we are saying. Now, how does it help us? When we plot this graph, it is helping us to determine how many people actually are having, let's just say, if I want to say, majority of the people who have cholesterol over 250 are more prone to heart disease because I see more brown dots. Okay. And the people who actually have less than 250 cholesterol are having less heart disease or something like that, or who have more cholesterol are. So that's the differentiation we are making. Actually, the target one in here in this data set, one means someone is actually suffering from heart disease, and zero means is not suffering from heart disease. Okay. So this graph in here, when we take out mean, this tells that, okay, people who have cholesterol more than this, okay, more than this. So we see yellow where we see a lot of yellows here in this section. We're having cholesterol less than this much, so they are technically shown to have heart disease. But we can't judge heart disease only based on one factor. Hence, we take into account other factors as well. For example, max heart rate levels, and that is what we are doing in second graph. Okay, we are taking into account heart levels, max heart rate. Okay, that's what we are doing. So how many people so anyone who has heart rate over 145 or something is likely to have a heart disease, is likely to have a heart disease. So that is how we are analyzing this data. I'm sorry I took a lot of time to actually accomplish this, but is everyone able to understand the power of matplotlib and how you are analyzing this data, and basically what you are visualizing? Yes, no, yes, no, yes, no. Okay. Siva, what is your doubt? What is your doubt? Siva. Siva Ramachandran, what is your doubt? I explain what, man, always asking big questions, all of you. Um, be specific. Do what you want me to explain. This whole thing again, or what? Syntax is somewhat hard to remember. I know it is hard. That's why I say you need to practice. Even if I tell anything here, if you don't practice, you will never remember it. You have to do it over and over. Okay. So Siva, you want me to explain it again? This whole part? Yes or no? Siva Ramachandran. Brother, if you reply fast, it will be fast. I'll start fast. Okay. Thank you for replying. Okay, cool. So what we are doing? Okay, let's look at here. This is where everything starts after this. Okay. Here we are using object-oriented interface. We are using object-oriented interface. I said we have two type of interfaces. We have done a lot of plotting without object-oriented interface. When we do object-oriented interface, we have much more flexibility and we can do a lot more things. Okay. And when we use subplots, that means we are pretty much using object-oriented interface. That is what you need to remember. Okay. When we use subplots, it gives us two variables figure, and then we can have as many axes as I want to plot of each equal size and equal properties of what sort of subplot I am expecting. Okay. Then I said that in here, it is saying we want number of rows is 2 and number of columns is 1. If you remember yesterday's class, where we were doing this four plots where number of rows was 2, number of column was 2, and then we were saying four subplot graphs. In here, we are saying number of rows is 2, but column is 1. Hence, we will have stacked graph. That's how we'll be seeing. Okay. For example, like this. This is 2 rows, 1 column, right? That is what is happening in here. Share X true. Share X true basically means all subplots will have the same x-axis, meaning the x-axis limits and ticks will be synchronized across the plots. That is why you see that in both of these we have same x-axis. In both of these we have same x-axis. In both of these we have same x-axis. You don't see different x-axis in here. Okay. Then we are setting title, label, Y label. This is what we have already done. We are setting a legend. Okay. Now for legend, we are saying the legend should be of type scatter plot elements. Okay. So that is why it is taking these circles as elements, circle 1, circle 2, and target is what? Is only of binary value, which is 0 and 1. Okay. Hence it is setting it 0 and 1. That is what this legend does. Okay. Now, AX0, AXH line. Basically, this draws a line in between a graph. And what we are saying, this line would be of blue color. The line should be a mean of cholesterol, okay, for axis 0. And for axis 1, we said the line should be the mean of this TALH. And THALH is basically here, which is nothing but your heart rate. Okay. And I don't know why its name is TALH. So don't ask me. Okay. Now, that's it. And that is why you see this blue line. Apart from that, in the next line, all we are doing is plotting a scatter graph, each for each axis. So AX0, scatter plot, AX1, scatter plot. One is based on cholesterol, another is based on heart rate. That's it. Now, everyone understood? If everyone understood this, okay, then pretty much everything is clear. But let's do the last thing that's left in the in Matplotlib. Uh, so we have a lot of styles in actually Matplotlib, and as you can see, so many styles that we have and we can choose from. So assume I want to use Seaborn. If I want to use Seaborn wide grade, wait, wide grade is what? This is the name. If I want to use this one, I can use this style as such. There. Okay. Now what will happen? Assume I am creating a graph. Again, this is the same syntax we have been using. Okay. There's grade and stuff. We have been using the same syntax. All good and fine. Right. And I want to plot scatter graph. Okay. I want to plot a scatter graph, but I want to use okay, let's try. Okay. Okay. And then if I say scatter dot plot, hmm, why is this not working? I keep on getting confused. Over 50, and this should work, right? Scatter. Okay. Yes, it's a keyword, definitely. I know that scatter is a keyword, but I'm thinking why it's not plotting out. Because it should plot up, right? Because in here we are also doing the same thing, but it is plotting, but in here it is not plotting, which is annoying. Probably we are missing something. Okay, let me check. Over 50, we have data. Yes, we have data over 50, definitely. Right. Um, okay. Let's just say I have set to this, and I am setting legend and line as such, and then I'm so damn confused. I'll check it why this is not working. This is weird because this is working here, right? We are we are pretty much doing the same thing here. Why it is working here but not there? Okay. Why the hell it is working here but not there? See, this is working here but not there. Probably we are not getting some data there, and that is why it is happening like that. But you can see in here something really nice, that we change the style. Okay. I set CMAP to winter, and it completely changed the style to what we were having. So if you also see, because we have set it to Seaborn now, this whole grid style and everything is changed. So you can actually choose different type of styles. Okay. That's the only thing that's left. Okay. There are so many styles that you can cover up. I'll definitely share you this notebook. Okay. And that is the end of matplotlib. And that is the end of matplotlib. Now, guys, you need to do all of these practice by yourself as well. It is a lot as it seems. Okay. But you need to do this practice one by one by yourself. Okay, guys. Yes, no. You guys will do it or not. The data sets are same that we have used in the last class. I'll share my notebook. Anyways, I said just now, what are you listening? I just said I'll share you this notebook today, and you will have this notebook, but I want you guys to practice it yourself over from scratch so you guys will understand. Okay. We will have a exercise actually today as well. Okay. Yes, this is how a data analytics project is done. You actually do data analysis. For example, we did some data analysis here on heart disease, right? You plot some graphs, you do some data analysis, and then you draw out your conclusion. For example, in here, I can draw out a conclusion that people who are having a heart rate more than 145 or something are more prone to heart disease. That is a conclusion that you are drawing out of this data analysis. Okay. So that is how you do data analysis based on data visualization. Cool. It's nothing so scientific. Now, you guys have some time to ask me any questions that you want. And my phone just turned off, so I'm sorry for that. That's why my camera is also off. So let me turn on my phone because I'm using phone as my webcam. Mm, okay. Okay. What does a data scientist do? A data scientist actually, so there are two types of data scientists. One, a data scientist who uses an existing model, existing machine learning model, okay, I already shared with Blackbucks, so they should have shared it with you. If they have not shared, I'll ask them again today because I shared all of the notebooks and a README from the last class, actually. So I'll ask them again. I'll ask them again if they have not shared to share it with you guys. Okay. Um, I'll share today's notebook as well. And okay. So what does a data scientist do? A data scientist basically, there are two scenarios. Okay. One is you already have pre-made models. There are so many pre-made, for example, KNN, random forest, so on and so forth. So there are so many algorithms that you already know. You are supposed to decide which model would be the best to actually make the prediction on the data set that you have. Okay. Then there is second type. Then there is second type, which is like, for example, you don't even know what kind of data it is, and you are actually basically designing your models from scratch. So you are doing much more heavy customization, but that is extremely, extremely advanced level. Okay. Ideally, researchers do that kind of thing. At this level, mostly people only use libraries. Even at that level, a lot of people just use libraries. However, sometimes you need to do some over customizations, and that is where that advanced level comes. And that requires you to have very deep knowledge of statistics, maths, probability, and so on and so forth. Because without high level knowledge of probability, statistics, differentiation, integration, calculus, and so on and so forth, it will be really hard for you guys to actually design your own model. That is the truth. Okay. But you can do the same data scientist job with the models that you already have. Okay. How data sets will be made. So that is why, if you remember, uh, okay, 1 minute, new notebook, select, okay, file, rename, Scikit. So let's name it as sklearn. Scikit-learn is also called as sklearn. Okay. So let's name it as sklearn. And if you guys remember, then, okay, six, six, five, six. Why the hell do I not have? Why do I not have? Yeah. Why can't I have this right off the bat? So annoying. Okay. If you remember this diagram, okay, how are data sets made? Data collection is the first thing, right? This is also a job. This is also a job. When we are studying all the data science, data collection itself is a job. Basically, there are so many different resources from where data sets are made. Okay. Yes, we will start machine learning now, and I'll be starting scikit-learn now. Okay. Then the second step is data modeling and finally deployment. Now, this 6-step framework that I covered in our first class, where are we? Okay, where are we? Basically, we have covered up until these three parts. Now, okay, what problem do we have? So in matplotlib, okay, in matplotlib, what we were doing, for example, in this heart disease, we are evaluating this data. Okay, we have a data set of heart disease. We are evaluating this data. What type of data do we have? okay, this is the kind of data we have, this cholesterol data and so on and so forth, and something lies here, something lies there, and so on and so forth. Okay, so we are basically trying to explore and understand, trying to define a problem. This is what we want to figure out. So for example, if we look and study this data, okay, if we look and study this data, we will understand, okay, possibly what we are trying to figure out is like how many people with certain characteristic have a heart disease or not, right? So that is problem identification. Then what data do we have? So we are analyzing, okay, to detect, to basically get and solve this problem definition. This actually also comes from our data collection. Okay, so for a problem definition, we'll start collecting data. We collected that data, and then we'll mark that data, label that data with some sort of things, or it can be also an unlabeled data, and we need to figure out and define a problem definition. Then we have our data. We need to analyze that data. That, okay, this is the data. These are the things. It lies here. Maybe we do some data visualization. We do some refactoring. We try to fill in the missing parts and so on and so forth. Okay. And then we are doing some sort of evaluation. So that is where it is. Now, where are we heading towards now? So we are heading towards this, the last three sections. Okay. What features should we model? What kind of model should we use? And what have we tried? And what else can we try? Remember, I said that this is all an iterative process. There is no one way to know that, okay, what we are using, what we are supposed to use. Okay. But Scikit-learn itself gives us certain framework, okay, that, okay, how you can choose a particular data set. So there is this amazing website. I'll also mark it in the notebook that I'll share with you guys. Okay. That is, let me do it here. Something like this. Okay. So yeah. Okay. So if you go here in this website, let me try to zoom it. Okay. In this website, what Scikit-learn gives, it calls it estimator or something. Okay. Right, estimator, but we refer it as models. Okay. It is the same thing as calling model. So what it is giving you a framework, a cheat sheet sort of framework, as in how you can decide what sort of model you are supposed to use. And this is not like 100% sure short way, but this is a very good sort of starting line for you to figure out, okay, this is the model you will use. For example, right now we had this heart disease data set. Okay, so you start. How many samples do you have? Do you have greater than 50 samples? So yes, we had 300 there. Okay, so if you didn't have 300, it will say get more data. That is not enough. So it said, yes, we have more than. Then are you predicting a category? Okay, so what sort of category we are predicting? We are predicting, okay, disease and so it lies into some sort of category. Yes. Okay, then yes. So do you have a labeled data? So yes, you have a labeled data. Okay. Because we have labeled target and so on and so forth. So we have a labeled data. So that what we are, because we decided it is a binary classification sort of data where like we set target 0, 1, 0, 1, 0, 1, right? And we know that 1 means someone has heart disease and 0 means doesn't. That is why it is a labeled data. Okay. Now, if yes, do we have greater than 100K samples? So no, we don't have that amount of data. Okay. Hence, what we can do, we can use SGD classifier, or we can also use kernel approximation formula. Okay. Now assume we have, oh, sorry, do we have less than 100K samples? So no, if we have more than 100K samples, then we use SGD classifier or kernel approximation. But we don't. We have only 300 data points, right? It is less than 100K. So yes, it is less than. then we can use linear. Okay, we can use linear SVC. And is it a text data? Yes, it is a text data. So we can use naive Bayes. No, it is not a text data. Then we use KNN. Okay, what is a text data? Basically, you just have text and so on and so forth. And what is the non-text data? Maybe you have much more structured data. Okay, so you can use KNN. In our use case, we can definitely use a KNN classifier. Okay, and so on and so forth. So this is how you can somewhat analyze and know, okay, what is the right model for you. So this is just one way. There are so many different sort of models that you can use that Scikit-learn provides. Okay, got it, guys? Okay, okay then. So what is the Scikit-learn workflow? Okay, what is a Scikit-learn workflow? So Scikit-learn workflow. First step, okay, is get the data ready. You need to have a data ready, obviously. Okay, but a second step, pick a model. Once you have data, you really need to pick a model based on some sort of decision. Okay, this is the model that we'll be using because I feel this is the right model. Okay, third, fit the model to the data and make prediction. Okay, so you need to fit in the model with the data, make predictions, and so on and so forth. Okay, fourth, evaluate the model. You will evaluate the model. Okay, oops. Okay, fine. Then now maybe you're not getting right prediction. Okay, you're not getting right prediction. Your estimations are coming as wrong. So maybe we tried to get something, but okay, the estimations are all off the charts and it doesn't help us. So what can we do? Okay, what can we do? What we can do is we can improve through experimentation. Hence, we can try some other model. Okay. Finally, if something works, then save and reload your trained model. So this is the scikit-learn workflow. Okay. There. This is your scikit-learn workflow. Okay, cool. Now, hmm. Um, okay. So what do we do? We get data, we predict machine learning models. Okay, learning models. Basically, we try to see the patterns. Okay, we are looking for patterns. We make predictions. That is clear. Okay, what is scikit-learn is built on? Scikit-learn is built on NumPy, Matplotlib, and Python, of course, right? NumPy, Matplotlib, and Python. Okay, scikit-learn itself has a lot of machine learning models that we know. That is why we are using this library because it makes our life easier. It has a lot of machine learning models. Okay. Um, Methods to evaluate. And it also have a lot of methods that we can use to evaluate our machine learning models. Okay. So, okay, let us write this as well. So why? Why do we need scikit-learn? Okay. We need scikit-learn because built on fast NumPy, Matplotlib, Python, okay, and first class Python support. That's why. Okay. Then It has many inbuilt machine learning models. Then machine learning models helps us learn patterns in the data. Okay. Finally, machine learning models helps us make prediction. So this is why we need Scikit-learn. Okay. Cool. Okay. So what will we do in this whole process? Uh, Again, the same thing will follow this whole process. This is the process that we'll be doing. Okay. Uh, and what you should do, it is a library similar to Matplotlib. What I'm saying, listen carefully. Scikit-learn is a library. Okay. Um, okay. How you should learn it going forward. I strongly suggest you guys to follow along with the code. Okay. I strongly suggest you guys to follow along with the code. So whatever I am doing in class, I hope you guys make your machine ready with Jupyter notebook and also try, I'm sorry, and also try yourself. Okay. After every half an hour, when we are doing Scikit-learn, we'll have a small 2-minute sort of break where you can ask any question. Okay. Or you guys can just drop questions in the text. Okay. You guys can drop questions in the text because it is essential that you guys understand the process. Okay. Thirdly, try to go, if you had Mekan, I don't know how many of you paid attention to the first class. Try to go to the first class again. Do the refresher. If you have recorded video, do a refresher. Okay. It will help you prepare your brain going forward in the class, what we are doing. Okay. Now, okay. Let's do a sample prediction stuff. Okay. Let's do a sample prediction stuff. Whoever is raising hands, just type your question. Guys, don't raise hands. I think this is like 5th or 7th or 8th time I'm telling this. No point in raising hands. Just type your questions. Okay. So, firstly, get whoever is raising hand. Are you nuts or what? Like I just said, don't raise hands and you are raising hands. Are you guys okay? From okay. Okay. First, let's get the data. Okay. You want to get the data. Import pandas. Then import numpy as np. So this is something that we need definitely. Then how do we get data? Let's try to get our heart disease data set. Okay. How do we get it? Start typing, guys, when you think like this is how we get it. Okay. Heart disease. So we get our data as such. Now, create X features matrix. Okay. So what is this? Okay. What is this? Basically, in here, we are creating a feature matrix, and one of the feature is age. Okay. Or target or something like that. So whatever. Okay. So we need to select a feature that we want to work. Okay. So let's do that. So firstly, let's say X. Okay. And then we say heart disease drop, and we say target. Sorry. And we say X is equals to 1. Okay. Oh. Second, create Y labels. How can we do that? We can basically say Y equals heart disease. Okay. And then we are saying we need to get target as labels. Okay. And in here, 0 means no heart disease, and 1 means has heart disease. Right? This is what we are clear with our data set up until now. Right? Now, what we need to do? Choose the right model and hyperparameters. I explained what are hyperparameters in class 1. Okay, in the first class itself, I explained about this. Okay, this is why I said that, guys, first class is just like foundation. We'll start building on top of it slowly and slowly and slowly. Okay, so we are referring, if you see up until now, we are referring to first class so many times, again and again and again, and filling in the gaps. Okay, so we are saying import from Scikit-learn symbol import, and maybe we want to choose random forest classifier. Okay. Now, before going to random forest classifier, we need to understand what is a random forest classifier. Okay. So, let me find the right words. Okay, so there are usually 4 ways to predict, okay, anything is wrong or right. Okay, especially with our data, we have these 2 ways, like we have this target where like we are saying 0 and 1. Okay, then something is wrong or right. Okay, now 4 ways are what ways? Data can be true negative, data can be true positive, data can be false negative, data can be false positive. Okay, what is true negative? The case was negative and predicted negative. Okay, that is true negative. The case was positive and predicted positive. That is true positive. Okay, what is false negative? The case was positive. For example, someone had a heart disease, but it was predicted that the person doesn't. That is false negative. or false positive. The case was negative, but was predicted positive. Okay. So we need to be precise, right? We need to be precise. And with random forest, there are 2, 3 things that we actually take into account. One is obviously precision, which says what percent of your prediction were correct. Okay. Second is recall. What percent of the positive cases did you catch? Okay, fraction of positive cases. Third is F1 score. What percent of positive predictions that were correct? And so on and so forth. So that is what how you actually are analyzing your data. Okay. In here, we can use several classification algorithm. Okay. We are using random forest. It is mainly used for classification and regression. Okay. Mainly used for classification and regression. Now, there is a huge maths behind it, how it's done, and so on and so forth. Okay. I won't go into a lot of mathematical detail, but you just need to understand that what are the parameters that we are checking this thing on, and you need to understand what sort of algorithm this is. Okay. So this is basically a classification algorithm that we are using. Okay. Okay. Um, okay. So it usually work on basically, I don't know how many of you are much more familiar with your data structures and algorithms, but it basically works on top of trees and stuff, and that is where the random forest comes and so on and so forth. If you want to, you can actually look at Python implementation itself and you can read about random classification. Cool. So this is something that we are using. And boom, we have imported it. Okay. Now let's say our classification model, we are using random forest classifier. Okay. Let's say it. Right. And now we need to keep the default hyperparameters. So we are keeping default hyperparameters in here. Okay. So clf dot get params. Okay. Boom. So these are the default parameters. These are the default parameters. For now, we are just using everything default. Bootstrap, XYZ, so on and so forth. Okay, you don't need to know about it now. If you are very curious, you can look onto it on internet, what these mean. Okay. Now, finally, what do we need to do? We need to fit the model to the training data, right? And we are saying from Scikit-learn dot Scikit-learn dot model selection. Okay. Import train test split, right? And then what we need to do, if you remember, again, the first class, I told you about the splitting of data, that how we split data, where like we say 80% of the data is for training and 20% is for testing and so on and so forth. Okay. So assume test size, okay, is 0.2. Okay. 80% for training, 20 for testing. This is what we said earlier, right? X train, X test, Y train, Y test. Okay. Then we say train, test, split based on target, which is the classification that we are. Thank you. Yes. Which is the classification that we are working on. Okay. Which is the classification that we are working on. And we are saying our test size would be 0.2. Right? Finally. Uh, Give me 1 minute, guys. There's some issue. Give me 1 minute. Give me 1 minute. Give me 1 minute, guys, please. Okay. 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 Let's resume. So, okay. So we are doing this, right? And then we want to build a forest of trees, okay, from the training set, right? Which is X and Y. Correct? You want to do this? And finally, we are saying what we did. We created what? CLF, right? We are saying CLF dot fit. Okay. And we are saying X train, Y train. Okay. Boom. Something amazing happened. Okay. So something amazing is happening. And now, okay. Now we want to do prediction. Okay. So let's say make a prediction. Okay. So CLF dot predict. Okay. X test. X test. Uh, Test. Yeah. X test. Right. And then we can say for evaluate the model on training data and test data. Okay. Boom, 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 boom. Some prediction went on the test data. Some prediction went on test data. Okay. but we want to make sense out of it. So let's see. The CLF score, okay, X train, Y train, okay, CLF score, X. Let's first do this. CLF score, X test, Y test, okay, there. Cool. So we got some things. We got some things. And now, what else do we want? Wait. So what we did, we calculated scores. Okay. Now, let's get confusion matrix. Let's get accuracy score. Let's get classification report. Okay. So this all can be imported. All of this can be imported. It's hilarious. Like at the end of the class, someone types, what is the topic name? Okay. There is some random name. So from Scikit-learn metrics, we have classification report, confusion matrix, accuracy score, and so on and so forth. This is what we are getting. Okay. And now watch. Now watch. Because we want to print classification report, right? And that's it. We are printing classification report and we are saying the precision we are getting for 0, which is the target 0 and 1, is 0.78. Recall factor is 0.81. F1 score is. Now, if you remember just a while back, what I said, okay, precision, what percent of your prediction were correct? Okay, so you were correct 0. Which is 78% of the time for zeros and 85% of the time for ones. Recall, what percent of the positive cases did you catch? So you catched 81% of the positive cases for zeros and 83% of the positive cases for ones. Okay. Then there is F1 score. What percent of positive predictions were correct? Then it is saying 79% of your predictions or positive predictions were correct. Okay. And 84% of your prediction score was correct. Finally, support. So support is basically the number of actual occurrences of the class in that specified data set. Okay. This is 2635, right? What happens if there is imbalanced support in training data? Okay. It usually indicates structural weakness. Okay. It usually indicates structural weakness. Okay. So I'll type it here for you guys so that you understand what is what. Okay. Precision is basically what percent of your prediction is correct. Dara Siva Sankar, today's topic is introductions to algorithms. Okay. What percent of your prediction is correct? Yeah. Welcome. Okay. Then we have recall. Recall is what percent of the positive cases did you catch? Okay. Okay. Then that is what I'm explaining, Siva. That is what I'm explaining here. Okay. F1 score. F1 score is what percent of positive predictions were correct. Okay. And finally, support. Support is number of actual occurrences of the class in the specified data set. Okay. So these are the 4 things. So to anyone who is asking today's topic, tell them it is introductions to algorithms, semester 1. Okay. Yeah, this one is good. Organic farming. The organic farming is the topic, man. Okay. Right. Now, there's not a lot that we need to do. So let me rush a little. Okay. For example, if you want to improve the model, okay. If you want to improve the model, okay. Then you can try out different amount of estimators. Okay. For example, we are now setting up estimator from this 10 to 100 and so on and so forth. And for each different model, we are checking what is the accuracy, right? So model accuracy, CLF score, we are checking accuracy in here. So you can see that when is it becoming more accurate? So you will see 70. When estimator is somewhat around 70, that is when our model is most accurate. Okay. We can pass estimator as such inside random forest classifier. Earlier, we used default values, if you remember. Okay. Now, how can you save? Okay. How can you save? Oh, we didn't do the confusion matrix, right? If you want to calculate confusion matrix, it's just like this, confusion matrix. Boom. You can get confusion matrix. Okay. If you want to get accuracy score, you can do something like this, accuracy score. Okay. Is my voice breaking? Guys, hello. Yeah. Who? For anyone it is breaking, then it's your connection. I'm sorry if it feels like rap song, but it's not my problem. Possibly your internet connection is a big fan of rap songs. Okay. Okay. Then finally, how can we save this model? Now we already did it, right? We also did this whole whatever stuff, found out accuracy, and we found out that when estimator is at 70, that is the most accurate one, right? And what we can do if we want to save, there is a inbuilt library which is called as pickle, and you can dump your model, okay, in there. Okay. File not found. Okay, anyways, we'll do the 6th step later on. Okay, we'll do the 6th step later on, but up until now, everything should work. Up until now, everything should work. Yeah, it works. Okay, load and model, pickle load, open this. This is saved. If you go in here in your home, and if let's just say if I try to refresh it, okay, then you will see that there is this random forest model dot pkl pickle type and Scikit-learn, and you can just load it, this model. Okay, it creates a pickle binary from where you can just load it. So this is our introduction to Scikit-learn. We'll be doing much more with Scikit-learn, okay, in the next class. Okay. Next session, I think it's on Monday, but I'm 100% not sure, but it's possibly on Monday. I am also asking for more class, so it also depends, so that there is a constant flow. Okay. Now, if you guys have any questions in this whole process, let me know. It is very straightforward. I wrote all of these notes, which I'll be sharing with you guys, obviously. Okay. Most of it we have just imported from library. We have used the same libraries, pandas, numpy, which we have used up until now. There are few new keywords in here. We are using like fit, trying to fit in the model, so on and so forth. Mostly coming from scikit-learn, right? There is some things that we have used, but the concept, which is like 80-20 and so on and so forth, this is coming from class first class, right? Then we are making prediction, again coming from scikit-learn, score coming from scikit-learn, metrics coming from scikit-learn. So a lot of these are just library functions that we are using. This is the only part where I use some logic. Basically, it's a for loop ranging from 10 to 100, stepping at 10, so on, increasing 10 every time, and trying to check where we are getting the most accurate results actually. Okay, so we estimated that when we are setting hyperparameter at 70, that is where we are getting the most accurate result. Okay, it gives us confusion matrix. Okay, what is the confusion matrix and so on and so forth. Okay, which you can look at it, what actually confusion matrix is. Not really something that you need to focus on right now. Then you can get accuracy score we got, and we also know now how we can save our model and load that model. Okay, notes, I have already said I'll share the notes. In which language, again, I need to tell that I'll share the notes. Okay. Okay. Today's topic, organic farming and introduction to algorithms. Why I use, because it's a classification algorithm. So you can use KNN as well. That is also a classification algorithm. There is no right answer to using anything. It completely depends on what is getting you the right predictions. This is why I said, if you look at the first diagram itself, it is an iterative process. Attendance link might be above or something. I think it was shared by Blackbucks. Don't ask me again. Okay, no one has any other questions now? Then I'll drop. When the class comes, I'll tell you. Sai. For now, focus on what I have taught up until now. I'll send notes. I have already shared some. I'll share today's notes as well. I don't, I'll ask them again why they didn't share it with you. So I'll ask them to share it with you. Okay. Okay, then. Bye. Bye, guys.